In this video we're going to be covering the capture animation utility that comes as part of the CAT toolbox. I'm going to start by inputting some motion into the max scene file and then mapping it onto my marine rig using capture animation. So I'll start by importing the data. Now we can import this data into Max using any importer we choose. We can use any of the ones that are written for CAT, or we can use any of the ones that come with Max, such as the FBX importer, the HDR importer, and so on and so forth. So if we import this gesture file, we want to create a new skeleton rather than apply it to an existing skeleton, and we'll leave all the settings to the default, so we import all the animation and the entire time range. So we press OK, and what this importer is going to do is create a bone skeleton that will be animated, and we'll use this animated bone skeleton to drive our cat rig. So here we are, the motion has been brought in, and we can see that it is a lot bigger than our cat rig. So we need to start by scaling this motion down. So we select the root of the hierarchy, which is this point helper here, and we scale it down to fit our cat rig a little more closely. So if we just move it on top of our cat rig, we can see a rough approximation of the size, and we'll probably need it to be a tad bigger. So here we go. We have an animated skeleton, and our next job is to map this data onto our cat rig. So we start off by opening up the capture animation dialog box, and we have it here in our viewport. We need to pick two hierarchies. The first one is our source objects. So we click on source objects and we go into a picking session, and we need to pick, first of all I'll just open that up. So we need to pick the source objects, and if we click on here we get our source hierarchy is filled out, and we can see the naming conventions that have been used on the skeleton. Root, upper back, thorax, and so on. We also need to pick the target rig, so just move that all across there, and if we pick target rig, we need to pick our cat rig, which unfortunately has been hidden. So the next thing I need to do is unhide it. We might hide the skin mesh at this point, unhide the cat rig, so we can see the cat rig is underneath the skin, and now when we come back here we can pick our cat rig. So we have now two columns, our cat rig and an associated capture node. Now this is the node we're going to be using to capture animation from. So we need to generate a mapping between our source nodes in our scene and our cat rig. There's a few ways of doing this. The first one is to identify the node we want to drive our cat rig. So one of these nodes might be, for example, the pelvis bone. So here we've got a bone called upper back, and it's got roughly the right transform for our pelvis. So we can just simply drag the upper back, and as you can see, when we select nodes in the scene, they get selected here. So we can just simply select it. We can see, okay, upper back here, drag it and drop it onto pelvis. Now we can see here now our characters, our cat rig skeleton is being driven by the HDR skeleton. So we'll look at other ways of mapping bones. Another way, if we just move that window out of the way, another way is to simply zoom in and select a cat rig bone. You can right click on a bone and click on the map bone. Now this right click menu option is only available when we have the capture animation window open, but if we select map bone, we just need to pick the bone in the viewport which we wish to map. So here we are in our viewport. We can now see rib cages mapped to thorax. Keep on going. So the next one we need to map is the head. Right click on the head, click map bone, and choose the bone we wish to drive the head. So if we zoom out just a wee bit, we will scrub through the timeline, and we can see that basically the entire upper body is being driven by the source hierarchy. So we need to work down the other bones. We could do this by selecting the upper arm, map bone, pick the shoulder. We need to, when we're doing this manual map bone process, we need to always make sure that we have the first segment and a segmented bone selected. So we right click here, press map bone. So if we select any other segment, it doesn't really do anything. We need to always make sure we have the first segment selected. So map bone, it's not a terribly time consuming process. It helps that this hierarchy is fairly well aligned, so our adjustments, we don't really have too many adjustments to be made. But now before I continue, I'm going to just show another feature of the capture animation dialog. We've got a few bones here mapped now, but there's a tool called AutoMap, and what this does is it tries to generate an automatic mapping between the source hierarchy and the cat rig. So it uses the naming convention in the source hierarchy and also hierarchical conventions to try and derive an automatic mapping between the cat rig and the source hierarchy. So if we press the automap button, we shall see the results. So it's mapped most of the bones. It's got it's skipped the spine. We have a procedural spine, so there's no need to map all the bones in the spine. However, if we had chosen to use an FK spine, we could map those bones. We haven't mapped the fingers. The source hierarchy doesn't include any fingers. Well, it includes one, but we haven't got any particular finger to map it to. We could still go in there and manually map this finger to the bones that we felt like we should drive using that bone. So we've got the hand and the wrist all mapped, and the head has been mapped also. So if we scrub through the animation, we can see it's done a fairly good job. There's been some mistakes, one of them being that the head has got a rather large offset on it, which doesn't seem to be correct. So we need to start correcting some of these issues. We simply select the bone, and if we go to the layer manager now, we have a layer called gesture mapping, and gesture is the name of the file, and so gesture mapping is the layer which maps the data from gesture onto this cat rig. So to adjust the mapping, we just need to do some rotations and just make sure these bones line up. So if we go back to the T-pose, we just need to check that our cat rig is getting a rough approximation. Now that's pretty close. First of all, there's a blue cross here in the viewport. When you select the head or the rib cage, a blue cross gets drawn. Now there's been a strange offset applied to the head, and also we can see the blue cross for the rib cage is a long way up in the air. What this means is the rib cage is trying to reach that point up there, and in fact we would prefer it if it was trying to reach the point somewhere on the rib cage that we're mapping to. And this is just an error in the automap process that can easily be fixed manually. So if we try to grab the rib cage and pull it down to correct this mapping, the rib cage actually is limited in its motion. We're not allowed to manipulate the rib cage up and down. This is just a sort of a safety mechanism to stop people accidentally ripping the rib cage up. But we can turn off this safety mechanism by just turning off spine limits movement. This allows us to just simply pull this value down, and what we're going to do is make the rib cage try to attain a position somewhere here. So it's going to be fairly close to its target, and if we select the head, we can see the head's goal position is quite low, so we turn off spine limits movement. The spine and the neck are identical and they have the same controls. So this means now that the head is going to achieve that position right there. So we need to zoom out a little bit and have a look at this pose. Firstly, our cat rig is a little bit too small for this file, so what we can quickly do is scale this motion down, make the character a little bit more relaxed. And also, one other tool we could also use is retargeting. So suppose we didn't want to scale the motion because its global movement was important. We could use retargeting, and what retargeting does is just adjust the height of the pelvis to fit the data. So this means that even if the legs are too long and our IK systems are snapping straight like we could see before, the retargeting helps us fix this problem. So now we can actually scale the motion quite a lot, and the cat rig will still maintain its leg angles. Of course, in some situations it's simply not possible, but we can see here that the cat rig is doing its best to fit this data without its IK system snapping straight. So A few other things we need to look at. First of all, the foot. The feet often need to be corrected. The ankles, we need to configure the feet to make sure they're flat on the ground. Turn off angle snaps and just rotate that foot to be flat. You can see the plane here, and rotate it on the other axis. So yeah, we also probably need to move it up. So all these adjustments, they're going straight into this the mapping layer that we were looking at before. So it's storing all these offsets for us. Oops. So we need to make sure the toes are aligned along the length of the foot. It's been mapped slightly wrong, and the ankle also is slightly off from what we would prefer it to be. So when I rotate the ankle, I'm actually going to use world space to make sure it rotates straight down rather than around its own local axes. And when we twist it, we'll use local. So here we got a fairly good alignment now. Maybe flatten that heel down and lift the toe up, so make sure it's flat. So what we're trying to make sure our character achieves is what the same pose that the character has in setup pose. So if we go back to setup pose, we can see that the ankle and the toes are aligned and the feet are very flat on the ground. So come back to this motion and it looks fairly similar now. And the other ankle needs to have a few things tweaked also. So let's start off by flattening off the foot on the ground. Okay, and we need to fix the toes as well. Okay, yes, that's looking a little bit better. Maybe straighten the toes out. So that foot now is looking a lot more accurate, and we need to flatten this ankle right down. So the auto mapping process is only an approximation, and therefore it will often get things slightly wrong. And it's your job as the artist just to validate the results and just make sure that you are getting what you expect. Often motion capture skeletons might not actually all that accurately represent the skeleton of the character they've captured from, so we might need to do some adjustments. So now we have this motion mapped. We're happy with this mapping. What we should do now is save this mapping so that we can use it later. So we press on the save button in this capture animation dialog, and we'll generate a name for this. What we're going to do is just use this marine to MotionWorks. Now MotionWorks was the files we're working with, and this will generate a mapping from the character we're working with to any of the motion capture files that came from that data set. So typically, if all your data has identical naming conventions, you can just generate a CAM file, capture animation mapping, and then from then on you can just reuse that CAM file over and over rather than having to redo this mapping. So once we've saved that, we can reuse it at a later date. For example, just as an example, I will throw away this mapping layer, so our character's lost all its mapping and we're back into our base pose. If we restart the capture animation dialog, we've got the loaded cat rig but no capture nodes, so we simply load the mapping file. And now our character's been mapped and all those offsets that we spent time adjusting have been loaded on. So now we're going to capture this motion onto our character as keyframes. Right now, all the capturing process is purely procedural. So let's just turn retargeting back on, because the mapping file doesn't store the retargeting values, as retargeting is a shot-by-shot basis, and it's simply not stored with the mapping file. So here we have the motion as we'd like it. We decide the time range we're going to capture, roughly frames 200. Ooh, what happened there? Roughly frames 200 to his head is something strange is happening. 200 to 700. So we choose these time values, and I'm going to set the frequency fairly high to make sure it happens quickly, and press capture. So what's happening is all this motion is being baked down to keyframes, so we can save those keyframes to a file and reload them, and we no longer need the skeleton in the scene. Now, we close down this utility, and we can see we've got keyframes now on our cat rig. Any bone we select has got many keyframes, and all these keyframes have been spaced 5 frames apart. So we can simply select our cat rig and press delete. Our source hierarchy. Our cat rig still retains its motion, and if we come to the layer system, we've got this mapping layer is still there. We just need to delete it because it's no longer of any use. And here we can see all this motion data is now on our cat rig. And that's the end of this presentation.